James, Wendy, I'm very sorry. I thought I was recording this whole time, and I just started the recording. I'll have to give you notes for the whole first part of class.
It's humanities. Humanities.
Elias, I did what you said. I am broadcasting live on YouTube. Yeah, that's crazy. I didn't know that that worked. Hello. Elias, I did what you said. I am broadcasting live on YouTube. Yeah, that's crazy. I didn't know that that worked. Hello. Of course, there's a delay.
Yeah.
All right.
This is for the associates, right?
Yeah, for your there's 8 months.
Yeah.
What are you studying?
Yeah, just general right now. And then, yeah. Hopefully by.
If I can knock out more classes, yeah, I mean,
I think all I need to do is, just math that'll.
so what's the one?
Yeah,
Yeah.
it's just a computer class.
Oh, but I heard that's like it's like 3 months or something.
Just the regular the semester. But these teachers like we're just having.
Yeah, but I heard that it's only finished in like 2 months.
So you can do the class.
That's what I heard.
To the salary. Yeah, I mean you could, but I just prefer it.
Yeah.
That's probably already.
Understand? Yeah, I do. All the
That's
time.
what I'm thinking.
I don't understand anything else.
Yeah.
Chapter 17.
You didn't understand it? I thought that was the easiest one for me.
I'm gonna have to go and Cengage and look at the videos again.
You know, those videos really help a lot.
The only reason I finished is homework.
Yeah, because like they give you like step by step, and when you finish it like this, like you see, you're like, damn, that's a lot. But then if you're like on the video, like you're actually doing it, like as the video's going, you're doing the homework.
It's only
really
7,
fast.
but
Yeah.
So the videos are in like 5 minutes.
5
minutes,
seconds.
you know.
Yeah, and the first like 1 minute is, you could just skip
You're
the
taking
first 1 minute.
Yeah, because
Yeah.
it's like explaining like definitions of whatever
That
you're
you
doing.
already know.
Yeah. Yeah, those videos
Yeah,
really
so I
help
was
me
taking
to understand,
accounting,
like,
so
because sometimes like when I'm in class with
take
her,
more
like
classes.
I don't understand, so I just go back to the video and I understand it, and like I try to put like whatever she told us like into like the video thing, and I'm like, oh, okay, now I get it.
I just don't do
You've been doing
here,
your
you
notes
have
that
to,
you have to put in on
have
Cengage.
I didn't do
3.5
17.
I didn't do 17 or 18, and she sent me a message like everything was okay, and I'm like, they just
do an
take too long, and I don't think it's worth it.
And then you have to do
Mhm.
a resume.
Yeah, I told her that, and she just laughed. She's just
Yeah,
like,
no.
okay.
Yeah.
She's like, hang in there, Karina.
Well, what is it though?
Oh, yeah. It's
So
the
it's like 3 pages long, and then some of the questions are hard to
higher than the standard.
And I get annoyed on this.
I mean, is there like a certain career?
But you know,
field
like
that
it's
you
that
wanna-
point, and you're like, oh, it's
I
just
wouldn't
kind
have
of
thought
but then like
that.
her grading, it's like
Yeah.
I mean, if
her
you
grading like right there, you know, so you're just like,
And the more I get like math, and
It'll
it'll kind of
help
help
you
me.
determine, yeah.
I'll start doing it,
I wanna go into.
even though I don't want to.
they want someone else, and like, because
Yeah,
right
so
now in
do,
our
like,
table,
private
it's like
careers
it's
and
4 of us.
positions.
Oh, all you guys get
So
together and do
I'll
it.
pretty much be.
Like we just
private
like call each other,
business
like text each other, and be like, oh, like you know, like
and all that stuff.
Oh, yeah.
like if we have like this the chapter 18, like the middle part was like a little bit long. So I wasn't understanding that, and then as you said, I wasn't understanding it. So we just kind of came over the notes like all together, and like we just put it out differently because it's just notes, you know, it's just like
Yeah.
for her like to see where we're at. It's not like actually like she just gives the point just because you're doing it, not because if it's right or wrong. She just wants us to have like an idea of what we're gonna be talking about that day.
Yeah.
So I think that's why I turned around just a little bit yesterday because I was actually reading through the book to finish the notes. So a lot of stuff that I wasn't understanding, like when I was doing the notes, like when I went in there, like she made it clear.
Is
Did
this
you
your
get
what, your
chapter
second
18?
semester here?
I did jump in.
I was
It was
kind of
pretty easy, I
situation, I'm
think.
doing part-time.
Yeah.
So I'm taking.
Financially, if you don't like all of it.
That, if you're having a manager.
Yeah. Like I know something that they just do both of them, they're just like, yeah.
Yeah.
Or, wow.
Oh,
It's time passes, but let you get.
It's really
Well, that's okay, that doesn't mean, well, I don't want them to go wrong. Only then can we actually give you some information. In case you have to know about the future, you'll be able to know what to do.
All right, folks. I think everyone's back except for Kristen. But she's on the phone, so we're just going to get started. So, number 9, moving on. Now, again, folks, here's something very, very important. Everybody with me? Not done. Everybody, okay, there we go. What is the difference between these two things? What is f of x telling us? What? The y coordinate. Yeah, the y coordinate. This is so important. You should tattoo this on your face or on your hand or something somewhere to remind your brain to keep thinking of the right information. That when we say f of x, that when we're graphing the function, it's telling you the y coordinate. Whereas f prime of x is telling us the slope of f of x. Right? It's the slope of f of x. But so now here's the crazy thing. Like, is this graph? Oh, that's the graph of f of x. See, when you're looking at the graph of f prime of x, let me just go back. There we go. So we all agreed that this was the derivative, right? This last one. So that's the function f of x. This is f prime of x. Now the thing is, even though this is f prime of x, when you look at the y coordinate on this graph, the y coordinate is telling you the value of the slope of that graph, right? So f prime of x, there are also y coordinates there. You know, you're looking at all these y coordinates. How high up is it? How high down, or how low down is it? And so the y coordinate of f prime of x is telling you the slope of f of x. It's just a mouthful. It's a lot to think about, but we really want to always concentrate on what these things are actually meaning. So let's take a look at this one. This is the graph of which? F of x. This is the original function. So if I look at any given blue point, that's the y coordinate. Like right here, the y coordinate is 3. Right here, the y coordinate is -2. And here, the y coordinate is -1. And here, the y coordinate is a little above 0. And here, the y coordinate is -5. So you can sit there and move your finger along saying, okay, what's the y coordinate? What's the y coordinate? Or you can change your way of thinking and say, okay, now what's the slope? Right? What's the slope right here? 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 And then all of a sudden you're talking about f prime of x. Okay, that's all. Just really trying to nail down this difference. So use the graph of f of x to estimate the value of f prime at -1. So we're just estimating. So I go to -1, and what's the slope right now? Just as a ballpark.
Oh, like the actual like number.
Yeah, well, yeah.
1, 1.
And maybe -1/1. Honestly, if you just said negative something, I'd be fine with that. The slope is negative something. Right? It's -1/1, -2/1. Who knows? You'd have to get out a ruler. And so f prime of -1 is negative something. So you should write down something like -1. So what's the slope at -0.2? So 0.2 is just to the left a tiny bit. Oh, well, that's obvious. What are they referring to? Yeah, they're probably talking about the bottom of that graph. So the slope, the f prime of -0.2 is probably 0. That's probably what they're shooting for. Whereas f prime at 1, what's the slope at 1? Positive something, but probably a bigger number, right? Maybe +7, +8. I mean, who knows? That's pretty steep. I mean, if you compare my pen right here, that's incredibly steep. Compared to earlier, that was just so steep. You know, that's just a nice little diagonal. Whereas this is super steep. All right? That's it. That's all there is to that problem. I think Math AS will accept a window of answers. So like for f prime of -1, if you enter anything between, you know, -1, -1.5, -2, somewhere in that window, they'll probably give it to you.
Type negative something.
Can you type in negative something? No, unfortunately no. All right. Again, this is the graph of a function. Choose the graph of its derivative. Okay, well, you all now have that new technique that I just mentioned. You might take your pencil and move it along and say negative, 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 0, positive, 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 0, negative, negative, negative. And choose which one of those graphs is the correct derivative.
That's the same graph.
Wendy and James, I'm sorry, this is the worst video ever. I cannot get it to focus on anything.
Yeah.
Did you all make a choice about which one it was? I heard Adon say, that it's the same graph. Does it look the same? Or maybe it shouldn't. So the values should be negative, 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 and then 0. So my value should be being negative, 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 0. Negative, 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 0. Negative, 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 0. Okay, well, so far that one could be it. And then my value should be positive, 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 0. So they go positive for a little bit and then 0. And then my value should be negative, 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 and indeed negative, negative, negative. Okay, did you all choose this one?
Yeah.
Oh, good. What'd you say, Daniel? No? Okay. All right, well, there you have it. That's 3 different ways that you can think about finding a derivative graph from the original.
So it's going negative, negative because it's like from the infinity?
Yeah.
I mean, this like.
Yeah. This goes down to infinity.
Okay.
Yeah.
So then it's like going up to 0 and then positive and down again.
Right. Yeah, so again, see, looking at these coordinates, we could even just try to go backwards. Right now, the fact that these y coordinates are negative means that the slope should be negative, right? So you could go backwards. You could start here and say, everywhere from here over, the graph should have a negative slope. And so do I go up here to -1 and does the graph have a negative slope? Yes. And then everywhere from here to here, my slope should be positive because the y coordinates are positive. And between here and here, is the slope positive? Yes. And then everywhere from here over, the y coordinates are negative, so the slope should be negative. And over here, indeed, everywhere to the right of that, the slope is negative.
Okay.
Yeah. Again, this is very challenging for the brain to flip back and forth.
Why wouldn't the middle one?
Great question. Why wouldn't the middle one work? So right here, the y coordinates are positive, which means the slope should be positive. Positive. But over here, the slope is not positive. The slope is negative. And then here, the y coordinates are all negative. The y coordinates are all negative, which means the slope should always be negative from here on out. But the slope is only negative for a little bit, and then positive, and then negative. So I know that there's a wiggle right here, but what we're looking at is the value of the y coordinate being negative. And everywhere in here, the y coordinate is negative, which means the slope is always going to be negative. And if you look to the right of -2.5, is the slope always negative? Here it's negative, but then it's positive, and then here it's negative. Does that answer your question? Yeah. So really, truly, folks, this is mind-bending stuff to keep track of what we're talking about. Probably the best thing that you could ever do is just actually take this graph and actually just make up values. Like if I were just to go right here, I'd say, okay, my slope should be -5. And then right here, my slope should be -3. And then right here, my slope should be 0. And then right here, my slope should be +1. And then here, my slope should be 0. And here, my slope should be maybe -2. And then I would tell myself, those are all the y coordinates of this graph. And so then I would actually go ahead and try to make that as a graph. And I'd say, well, over here, -3, it should be down here to -5. And then here, -2 should be down at -3. And then here it should be 0. And then here it should be a little high up. And then here it should be 0. And then here it should be down -2. And whammo, I start to see what my graph looks like by just plotting all those points. Okay. So that's two different problems. The graph of the slopes of the red function has which color? So which one of those straight lines represents the derivative of the red graph? Again, this is practicing our conceptual understanding and flipping back and forth between the function and the derivative. So which one's the function? The function itself? Yeah, they're talking about the red one. So they're saying, okay, look at this red function. That's our f of x. Red is f of x. You might want to label it. The red one is f of x. And so you might just want to look now. So let's follow along the slope. Positive, 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 0. So it's at this x-coordinate that the slope is 0. So the y-coordinate of the derivative should be 0. So it's the black one. The black one is the only one that cuts through the x-axis. And remember, the x-axis is when y equals 0. The y-coordinate is 0 on the x-axis. So since we're going positive, 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 0, at this point, the derivative function should have hit 0. And sure enough, these y-coordinates here are all positive. The y-coordinates here are positive. You know, like this is up 3, this is maybe up 4, that's maybe up 5. And then if you go to the right on the red function, now the slope is negative. And that means the y-coordinate of the derivative should be negative. And sure enough, the black graph has now dropped below the x-axis and the value is now negative. I'm not entirely sure how each and every one of you feel about this right now. It is difficult to talk about, switching back and forth between the y-coordinate of the derivative versus the y-coordinate of the function, and the derivative of the function versus the y-coordinate of the derivative. It's pretty tricky. So how about this next one? Which graph is our function? Still the red one. So we're looking at this red graph right here. The graph of the slopes of the red function has which color? So we're looking at the red function. And again, we might just want to follow it along. So positive, 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 positive. And is that where it's 0? Is it 0 right at 5?
Yeah.
So it could be orange or blue, right? Orange and blue both have a y-coordinate of 0 at 5.
But then the positive. What's the red positive slope?
Right, but yeah, keep in mind this red function is always positive sloping, except for at 5 when it flattens out. So since my derivative is positive, 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 it's got to be the orange one. Because the orange graph always has positive y-coordinates, except for when it bottoms out and touches the x-axis. What did you say, Rosa?
Well, because like it never went down, right?
Yeah, exactly. Okay. So number 13, the function graph below has, so this is just more practice of writing out your intervals. So go ahead and jot that down, practice it one more time. What's the interval of positive slope versus the interval of negative slope? You don't think we're interrupting Kristen's phone calls, do you?
No, I don't think so.
Okay. I was really worried that we're interrupting her. Okay. So let's check answers. What did you all get?
Negative.
Which one are you sharing with us?
The negative.
When is the derivative negative?
Yeah.
Okay, so when is the derivative negative?
Plus u.
From where to where?
Negative infinity to 1.
And then?
2.5 to infinity.
Yeah, very good. 2.5 to infinity, roughly that. Okay, good. So that would be negative infinity to 1 union 2.5 to infinity. Did I get that? Okay, and then where is the derivative positive?
Negative.
Yeah, from negative 1 up to 2.5. So negative 1 up to 2.5. Now, folks, I just want to encourage all of you. You've seen now over and over how I use my pen, right? I'm using my pen as a slope indicator, right? So anytime I want to really make it concrete what the slope is, I'm using my little pen to ride along the surface. So I hope you feel free to do that too. Like when you're doing your homework, you know, maybe at first you feel silly. Like you're like, oh no, I hope nobody watches me. And you're like going like this with your pencil. That might feel silly, but it's helpful. It's really helpful. So I hope you do it. Okay, let's take a look at Math AS. Nobody at the beginning of the class said that they had a question, but I just want to point out, I can use this. I just want to point out some options that are available to you. So first of all, you guys see these messages here?
Yeah.
I currently don't have any from any of you.
Oh no.
Right, so I really want to encourage you, send me some messages. Email me, say, hey, I don't know how to do this problem. So just remember, every day I log in and I'm like, do I have any messages? No. So I am available to you. I'm your resource. When you're doing this homework at home, you can contact me.
So what time?
Yeah, for free. I won't even charge you.
He will answer
He'll
he'll answer
Yeah, I'll answer late.
Yeah.
I try to answer before I go to bed. That's the key thing. Before I go to bed, because I don't want you to have to wait until the next day.
What time do you go to bed?
Normally midnight. Okay, so folks, here's 2.3. I don't imagine anyone has any questions on 2.3 because we just did it. Like we just did all of 2.0. Oh wait, sorry, this is 2.2. I'm sorry, let me go to 2.3. Oh my gosh, are they both 2.0? I opened one of them to be 2.3. What the heck?
It flipped over to 2.3.
It did, it just changed on me. Okay, assignment 2.3, here we go. So I don't think we have any questions on this because we just did every single one of these problems. But does anyone have a question while I'm here? You see, they're all the identical problem. Well, not identical. They're not identical, but they're very similar. And that's what you'll do for homework. Okay, so let's look at section 2.2. Because here you might still have a question. Does anyone have any questions about any of these? I'll just click through about finding. No, I'm back on 2.3. Why does it do that?
See.
It'll only let me open in one window at a time? That's crazy. What kind of technology is this? Okay, so assignment. There we go. Okay, we're definitely in 2.2. Does anyone have anything in here in 2.2 that you wanted to look at?
Everything.
Everything? Because I might imagine that you would want to see one of these. We didn't do all of those. We did that one, or something like it. We did that, or something like it. We did one of those, but we could always do another one. Yeah, or like this one.
We didn't do, well, some we did not.
Yeah, we could do that one, 7, 8, or 9. Okay, that one we've already
Yeah, we
done.
didn't do 9, 8, 9.
Yeah, so okay, so let's take a look at 8 of them. We didn't do 12 either, but this 12 is easy. It says take the limit as t approaches -2. Is there any reason why you can't just plug in -2? No. You can just plug it in because you're not about to divide by 0. And that's the only thing you have to avoid. You have to avoid dividing by 0, but that's it. So right here, you just plug in -2, and that would give you what? -24 plus 10, so -14. Theoretically, that's the answer. Let's try. If I just did that computation correct. -14. Hey, well, okay, so yeah, that was right. Okay, so somebody said number 8. Let's see it. If you want to write this down, go ahead. If you just want to watch, and that'll tell you how to do it later on, that's fine too. So we have -9x plus 72 all over x squared minus 12x plus 32. Did I get that right? And we're taking the limit as x approaches 8. So keep in mind what we're doing here. Can I just go ahead and plug in 8? I mean, I can try. I can try to plug in 8. But if I do, I get -72 plus 72 in the numerator, which is 0, which isn't necessarily a problem. You know, if it came out to be 0 over 10, that'd be fine. 0 divided by 10 is 0, and that would be the limit. The limit would be 0. But we have to check the denominator. 8 squared is 64, minus 12 times 8 is 96, and then plus 32. 64 minus 96, that's negative 32 plus 32. Okay, that's a problem. 0 over 0 is undefined. So that means right there I must have a hole, a jump, or an asymptote. I don't know what. I would have to graph it to find out. So what are we going to do? What do you have to do? What should I do to the top, first of all? What can I do to the top?
Simplify.
I need simplify.
Factor it out.
Yeah, factor out a -9, that'd work. So x minus 8. Okay, so there I factored out the 9. And what can I do to the bottom?
It'd be x minus 4, x minus 8.
Yeah, so you're just reasoning that out.
Yeah.
Right in your head. Yeah, so let's just check. What multiplies to make 32? 1 and 32, 2 and 16, 4 and 8. And which ones add to make 12? They have 4 and 8. So it'd be x minus 4, x minus 8. Now, we could have already guessed that it was going to end up being x minus 8, because we know that it has to be able to cancel out what the problem is. And we know that 8 is the problem. So once those cancel out, I just canceled the thing that caused the 8 to make me divide by 0. So now I just have -9 divided by x minus 4. And now I can plug the 8 in. And that's the key. Now I can plug in 8, which is what? -9 over 8 minus 4 is 4. So -2.25, that would be the limit. And if you actually graph it on a graphing calculator or Desmos, you would see that the graph actually has a y-coordinate value of -2.25 at 8, except for the fact that there's a hole there. So there would be a hole there.
So does math take it as a decimal or as a fraction or both?
Either way. I think either way. Should we try? I think I can type in -2.25. Yeah. Yeah, decimal's fine. You could have typed in -9/4 as well, I believe. Yeah, I took it either way.
Okay.
All right. So this one, what about, wasn't it 7? Yeah, how do we do 7? So in calculus, we're reminding ourselves of a lot of technical techniques, right? Tricks of the trade, like how to subtract fractions with common denominators. What's the trick in this problem? What do we have to know about? Specifically, there's a vocabulary word that I'm thinking of. How do we, well, first of all, can I just go ahead and plug in 121?
Yeah.
Okay, sure. I like your guys' attitude. You're like, sure, you do it. Yeah, why not? You know what I mean, though? I'm saying, what happens if I plug it in? I'll get 0, and up here, another 0, because the square root of 121 is 11, 11. So it's a 0 over 0. So I could plug it in, but I can't, because it doesn't equal anything. So how do I get rid of the x minus 121 in the bottom? And how do I get rid of this root x minus 11?
The bottom one, don't you multiply it by
Square the top.
Well, I can't just square something out of nowhere. Because if I have a fraction like 2/4, well, that's terrible, 2/5. If I have a fraction like 2/5, if I square it, I just change the value. Now it's 4/25. This was 0.4, and this was 0.16 or something. So you can't just square something out of the blue because it changes the value. What I am allowed to do is multiply by something on top and bottom, the same thing. Because if I multiply top and bottom by 5, what's 5 over 5? It's just 1. So I'm allowed to multiply by 1. That doesn't change the value. If I square it, that changes the value. If I multiply times 1, it doesn't change the value. But I don't want to multiply 5 on top and bottom. What do I want to multiply top and bottom?
X minus 121.
We've got a lot of good guesses. We want to multiply by the conjugate of one of those. Remember conjugate? Conjugate is the same thing, but one is plus and one is minus. So should I multiply by this conjugate, or should I multiply by this conjugate? I mean, ultimately, you can try both, right? You can just try both and see what happens. Well, if I multiply by x minus 1, oh no, x plus 121 on the bottom and x plus 121 on the top, let's look at what happens. Down on the bottom, I still have x squared. If you multiply conjugates, it's FOIL, but the OI terms cancel out, so it's x squared minus 121 squared. Now I don't even have to go any further than this. What happens now if I plug in 121 for x? It's 121 squared minus 121 squared, which is
0.
0. So we didn't get rid of the 0 on the bottom. So that was not the conjugate. That is not the droids we're looking for. Which conjugate should we multiply by?
The top.
Top one. Now let's see what happens. If I multiply by root x plus 11, now on the top, FOIL, first, root x times root x is root x squared. The middle terms cancel out, plus 11 root x, minus 11 root x, and then minus 121. Well, now root x squared is just x, right?
Yeah.
So now I've got this nasty expression on the bottom, which I'm not going to bother to FOIL. And then on the top, I just have x minus 121. Did you all see what happened? Yeah, that really exciting thing just happened. So there, that's what we were looking for. So we definitely wanted the conjugate of one of them, but it had to be the right one. And so now, what's left in the numerator? Just a 1. And now can I plug in 121? Yeah, because now the square root of 121 is 11, and now I have 11 plus 11. That's the key. We had to change that minus into a plus so that it wouldn't end up equaling 0 on the bottom. So now the answer is 1/22, and that's the answer. Folks, I am so happy to walk through all of the Math AS questions with you because I want you to have that support. So if you want to write all that down, go for it. Otherwise, we're all done. Thank you very much, folks. We're going to go back to the normal room next time.
Better camera.
What's that?
Better camera.
Yeah, that for sure. We just got kicked out of that room today because they were installing new lab equipment.